Good afternoon, everyone. I'm Jonathan Chang.
I'm Sienna Miertschen.
And today we're going to be presenting the final design proposal for Team Annihil-plate. Among the other members of our team, we have Quincy, Luna, and Warren. Okay, so let's start by taking a look to the past. What did we use in the surveys before we were using our compostable plates? So about prior to 3 years ago, we were using glass dishware in the surveys to serve food to the students. So basically, once people were done eating, they would scrape the food off into the trash can and insert the plates into the tray for the employees to clean and wash the dishes. Now, about 2 years ago, Rice decided they wanted to take the initiative to become a much more environmentally friendly school, especially in the surveys, by switching to compostable palm and paper plates. So the advantage to using these plates over glass dishware is that we don't have to use water and dish soap and employees' resources in order to clean these plates. And we're also helping the environment by using compostable waste. Now, let's take a look at the images here. How many of you are familiar with seeing this in the surveys? Give me a raise of hands. Exactly. So having this many plates and trash and food in general inside of the trash cans is creating a really big problem where employees will have to take out the trash multiple times per meal. And it's just really unpleasant to look at. Not only that, but students are directly throwing the compostable plates into the trash can. So it's kind of a waste of being transferred into compostable plates in the first place. So the current system of using compostable plates is quite inefficient and wasteful. So now let's look at space inefficient stacking of plates versus wood palm chips. So imagine you have a trash can, and we're gonna throw just normal plates inside of the trash can. You can fit about maybe 20, 25 plates before this trash can is gonna fill up because these plates are so incompressible, they're not malleable. And there's a lot of airspace in between them when you're just throwing them inside of the trash. Now imagine if we had some way to make these plates into a much smaller size. If we had shredded palm chips, shredded paper chips, no matter how you're orienting these chips or small pieces, they're gonna be at a much more dense state than if you're just having plates thrown inside of the trash cans, because there's less airspace between them and they're much more dense. So our problem statement is that Annihil-plate is seeking to design a device that can be put over the trash cans and will dice the plates into smaller pieces and will be completely operated by the students in the serveries. So let's look at our design solution features. So here on the right, we have essentially a sketch of our design drawn by our very own Sienna. And I'll start from the bottom here. So here we have a moonshot compost bin, which is the ones you see in the surveys right now. And we're gonna have an aluminum frame that's gonna hold up the rest of the device, in which there will be a rotating crusher. So rotating crusher is essentially what you see here. It's a series of 2 axles with aluminum blades on top of them, and they're gonna be rotating in opposite directions so that whatever we throw in them is gonna be completely crushed. Now on top of that, we have a bear box. So when I say bear box, that might be more of a niche term. So let me explain what that is. So if you ever go to Wyoming or a place with a lot of wild animals, you're gonna see that wherever you dispose the garbage, there's gonna be something called a bear box. So basically, it's a 3-step action. You open the tray, you put whatever trash is inside of the tray, and then you close the tray. And then after that, whatever is inside the tray will insert into the garbage disposal. So it's kind of like a mailbox. Essentially what this does is it prevents wild animals or people from getting inside of the garbage disposal and only inserting trash inside of it. So those are the 3 main components of our device.
So before our team was able to begin brainstorming ideas for a device, we had to come up with our design criteria. So these are a few of the constraints that we have for our design, things that have to be in our design. So since they're going to be in the serveries operated by students, they have to be really safe. So this means no exposed sharp edges and no exposed moving parts. Next is object compatibility. So this will be the objects that we're talking about are the palm plates. The device has to be able to fit the palm plates inside of them to crush the plates. So the plates are 12 by 12 by 6, so the device must be able to accept the plates into it. And then bin compatibility. The device has to be compatible with the moonshot compost bins in the serveries. So this means whenever the device is crushing the plates, the plate chips that are coming out have to be in a less than a 2-foot diameter because the moonshot compost bins they have a 2-foot diameter. And then these are a few of our objectives for the device. So these are determined by our client, Brad Thacker from H&D, and what we think our users might need in the device, and then what our team had imagined for the device. So first is ease of operation. Our team made a user-defined scale for ease of operation, as you can see here, and since it's going to be in the serveries, the device needs to be accessible by all. And then we wanted the device to be greater than a 3 on our user-defined scale, so we wanted it to be able to be used in 3 steps or less, and then accessible by everyone in the serveries. Our next design criteria was durability, so we want our device to last a long time. We don't want H&D to have to replace or fix parts any more than once a month. Next is compaction level, so this is the actual function of the device, how much it reduces the volume of the plates. So we want it to be able to reduce the volume to less than 70% of the plate's current volume. Next we have capacity. So our client wanted the device to be able to destroy at least 5 plates at once. So processing greater than or equal to 5 objects being plates. Next is maintainability. We need our device to be easy to clean. We don't want H&D to have to deal with a long process, so the parts in the device must be dishwasher safe. They must be able to be removed and put in the dishwasher, and the cleaning should not take more than 15 minutes for the people who work in the serveries. And then portability. The device has to be able to fit through doorways, which doorways are 7 feet by 3 feet. So once we had our design criteria, we were able to move on to the brainstorming phase. And these are a few of the ideas we brainstormed within each design block. The first design block, method of delivery, this is how the plates will actually get into the device. So first, we brainstormed the bare box safety device that Jonathan was talking about earlier. And then slotted entry. This is just another idea that we had. We did end up choosing the bare box device for safety reasons. And then the mounting system. We could so the ideas we had here, a wheeled table where we would move the device instead of the compost bin to be able to replace the bag. And then we had 2 where we would move the compost bin instead of the device to replace the bag. So that was mount the device on the wall, or have a stationary table or frame. And then last, we could attach the device to the bin, Moonshot compost bin itself. And then the last design block that we had was mechanism and motion. So this would be how the plates would actually get destroyed. So first we had shredders. If you could think of just a paper shredder like you would see in an office building, but maybe scaled up a little bit. I think rotating crushers would go along with that sort of device. And then compactors, maybe think of a hydraulic press just to compact the plates. Dicers, like a fruit dicer you would see in a kitchen. And then slicers like a paper cutter. But again, all these scaled up for the palm plates. And so once we had all of these brainstormed ideas, our team, we had 2 rounds of brainstorming. We generated about more than 40 brainstorming ideas, and we sorted those into the design blocks I just talked about. Once we had done that, we were able to move on to the morph chart phase, and in that, we used different combinations of the ideas in our design blocks. We created 15 solutions. With those 15 solutions, we moved on to the Pew screening phase. In that phase, we compared each solution to the hydraulic press, and considering our design criteria, we determined 7 of our solutions to be below that standard of the hydraulic press, and then 8 solutions to be above that standard. And those 8 solutions moved on to the common sense screening phase. In that phase, we determined 2 solutions to be unfeasible because they were both blenders, and we didn't think that would be feasible for this device. With the 6 solutions left, we moved on to the Pew scoring phase, which Jonathan is going to talk about, and we did end up deciding on the rotating crusher design, because the rotating mechanism is going to require less force than the other types of mechanisms.
Okay, so here's the P matrix that Sienna referenced. So first what we did is we looked at our design criteria. We thought, what design criteria is most important to us? And to us, ease of operation, durability, and compaction levels were by far the most significant criteria because those are the most effective in creating successful crusher. So after that, we looked at each one of our remaining solutions. We have rotating crushers, mechanical 2D actions, and lever-operated presses, and even conveyor belts. So after that, we rated them based on our design criteria, thinking how effective is each design solution at completing each one of these criteria. So rating on a scale of 1 to 5, completed this matrix, and we came up with 2 solutions with a score of 4.15, which is significantly higher than the rest of the remaining solutions. So in the end, we decided to go with the rotating crusher with the bare box. We decided to go with this solution because, well, as relative to the rotating crusher with the slot, which also scored the same score, because it was a much safer option, which is not a design criteria, but it was a safety constraint. So having a bare box limits anybody from entering any limbs or any parts into the crusher itself, which is a really big safety hazard if people are just sticking their hands into the crusher. If there was a slot, then anything could go inside of the slot and basically cause a hazard to the machine and the person using the machine itself. So here we have a more detailed look at our selected solution. So here are some specific parts divided into each design block. So starting with the frame, we have some steel connectors that are going to hold up the entire device. We decided to go with steel because it will be the most effective at creating a heavy base and being able to support the rest of the device. Going on to this, we have the rotating crushers. So the rotating crushers, again, there are 2 simultaneously spinning axles that have blades, and they're going to look like this. So it's basically a hurricane blade, and when I say hurricane blade, that means a circular blade, but it has like jagged edges that will catch onto the plates as they're being thrown into the crusher. In addition to that, there are steel spacers between each blade and a motor and a gearbox which will be used to do the rotating mechanism. Lastly, we have the bare box itself, which I already talked about earlier, but there will also be a momentary switch. So this momentary switch is going to be incremented by 1 every time this box is open or closed. And then that incrementation is going to increase the amount of seconds that the crusher is actually rotating. So for example, if we decide that 3 seconds per plate or stack of plates is sufficient for crushing, then we would add 3 seconds every time this bare box is open or closed.
So looking forward, last week we completed some low fidelity prototyping, as you can see on the right of the design blocks. We're in the process of ordering our materials so we can move on to medium fidelity prototyping and high fidelity prototyping. Our medium fidelity might look like 3D printed hurricane blades to see how well they catch. High fidelity might look like a few aluminum hurricane blades to see how well they can crush the plates. We plan to have our final prototype finished by November 30th, and then we've discussed with our client scaling this up into multiple surveys around Rice campus. So in summary, Rice Housing and Dining needed a way to reduce the volume of the palm plates in the serveries for easier transport and composting. Through several rounds of brainstorming, screening, scoring phases, Annihil-plate determined that the best solution for this problem would be a rotating crusher with a bare box intake design.
So we'd like to give some special acknowledgments to Moonshot Composting, which is the composting service that actually takes out the palm plates and all the composting food that we have. So they will be servicing all of the composted materials. And also Rice University Housing and Dining, along with our correspondent, Brad Thacker, who is funding this project. Special note about this, so since we are founded by Rice H&D, our budget for this project exceeds the amount that is given by the ODEC. So the amount that we spend on this project is not strictly limited, but that means we have more freedom to make a more durable and strong device. And also special thanks to our professors and our mentors. So does anybody have any questions about the device or the design solution or the design process in general? Yes, go ahead.
So you mentioned that every time the bare box is open, you would add 3 seconds to the time, because that would be like per plate. But what about if someone puts 2 or 3 plates in simultaneously?
Okay, yeah, so the question was, if we're gonna input more than 1 plate at a time, how would that change, like, based on how many seconds that the rotating crusher is running? So ideally, this rotating crusher is extremely strong. So no matter how many plates we're putting in at the same time, it should not affect the time it takes for the amount of plates to be shredded. Yes?
Would users have to scrape the food off their plate before using the device?
Yes, they would. But that's actually incentivizing towards us being composting, because if we think about what's going on in the surveys now, since students don't have to scrape off the food into the trash cans, they're just throwing the entire plate and food into the trash can. So we're not actually composting at all. But if we're scraping the foods off and throwing it into our device, then we're composting and getting rid of the trash at the same time. Yes.
How will the device be regularly cleaned?
Okay, so the question was, how will the device be cleaned? So as you can see here in this frame, this trash can is easily removable. So after that, we'll also have a compartment that can open. So for example, if this like face over here was able to be opened, we'll have like kind of a hatch so that the entire rotating crusher will be able to be removed, and any parts that are broken or any blades that need to be cleaned can be cleaned. Yes.
What's driving the size of the height? I mean, 60 inches, that's as tall as I am.
Well, yeah, so the question was, why does it need to be so tall? So, well, the main reason is because the entire bin, it needs to be able to fit above the entire bin. And essentially this bear box, we're having it this high because there needs to be like a space for the plate to drop into the bear box without falling like directly flat. So like if the plate was in this plane, it might create more problems if you don't have enough space for it to fall vertically. So we would have like a slot for it to fall directly vertically into the crusher. So yeah, that's why it's so high, but we can probably also look more into making it a little bit lower so it's more accessible for people with, like that are vertically challenged. Yes. Oh, yeah, go ahead.
The bear box is made out of wood, is that correct?
Yeah, that's what we're referring
Would it
to.
be possible to make it out of something translucent so that people can see this process?
Yeah, that would be totally possible. So we could make it translucent in order to have the students look at what's going on inside. Yeah.
If I throw in a button, please.
Sorry, can you repeat the question?
What if I use something else? I throw in something else.
Yeah, so ideally when we talked with our sponsor, he said that we should be focusing on the plates right now, but when it comes to us actually building the high fidelity prototype, we'll be able to see if it will be able to accept other products such as cups, plates with different sizes and materials. And since the crusher is, ideally it should create a really strong force with the amount of torque that it has, it should be able to crush. But if not, there will be some limitations to what the device will be able to intake. Yes?
What's powering the device?
Yeah, so the question was, what is powering the device? So it's going to be next to an outlet and it's just going to be plugged in.
Thank you very much. And now we are going to have the other team. Respond alert. Turn that.